Now, naturally, question will come that then what will happen in case of RR conflict for SLR one parsing table, right? So let's try to realize it. So now we will go through the conflict for conflict in SLR one parsing table. So assume that uh, so suppose that we have a state something like again I'm considering the same situation, like I have a, okay, just a minute, let me underline it first. So assume that we have a situation I state here which contains some production rule, say A to A dot and say B to alpha, sorry, not a dot A, sorry, dot A and B to alpha dot. Okay, so dot will be before A. And because of this, since you have seen that there is no difference in the state diagram, so definitely I hope you can understand that because of this small a, I will have a transition from this II state to some IJ state, right? And where you will basically write A to A dot or something like that, right? Now see, in case of SLR one table, what you are saying, what we say, like if we draw the parsing table again, say suppose that I have some non-terminals ABC including dollar. If we draw it, I'm interested only for this part, okay, not interested for the go-to part because there is no, there no scope of clash. So this is my ith row, and what we have seen, that in the ith row, on because of this small a, I have this transition. That means for this small a, so I will write S transition to J. That means I will write SJ. Now, in case of SLR one table, what we are seeing, we don't put reduce move in all the column, rather in the follow of the LHS. That mean that mean if we consider a situation like this, like if assume, just assume that means this B to alpha is the final item, and because of this ith row should have some reduced move, but not in all the column. Put under the follow of the left hand side, that means under follow of capital B. That means if, I'm sorry, not assume, if I say that if follow of B contains some elements but also A, some elements but also A, then only you will have this production rule. For example, B2 alpha, assume that this B2 alpha is some RPth production rule, then only this RP will be present. But if we consider, if we assume that, if we see that this follow of B don't contain this A, then RP will never come here. and naturally you will find no, there you will find that there is no clash, right? So that mean here I can say that the table, over here, specifically over here, the table will have, according to the example, SR conflict if this condition hold, if this capital B follow of B contain small a, otherwise not. Similarly, if you think a situation like this, another case over here, for the RR conflict we are considering that again A to alpha dot, one final item, B to beta dot, another final item, and assume that this B to alpha is RP, so definitely assume that A to okay, over here consider that A to alpha is say R pth production rule and B to beta is R qth production rule. Assume these two. Okay. So what is the basis of conflict over here? How I can say? I can say that you see, if there is a, if you have an intersection between the set that you will find for the follow of A and follow of B, and if you have something in the intersection, then only that is the common basically. So in that common cases only you will have the conflict. What I mean to say is that assume, I mean, let's write in a different color over here, not right. So assume that follow of A is say A, B and C, and follow of B is only C. So what will reflect on the transition table? In a parsing table. If you find, I'm sorry, no, it was not correct. If you see the SLR1 parsing table, I will have obviously A, B, C and dollar, and this is we are considering ith row as it is, as usual. And according to this information, follow of A and follow of B, that if we, this is RP, right? A to alpha is RP. That means this ABC will contain RP. Now, since follow of B contains C only, so definitely that RQ, this production rule B to beta, I will not put in these under this A and B row, A and B column. I will put under this column, but this will lead to some conflict. So how we can, how what basically what is the basically moral of the story? How we can draw the, draw the point over here, that in SLR1 parsing table, we will have RR conflict what is the basis of that? If follow of A intersection follow of B is not equal to phi. You see, if you take the intersection between this ABC, AC and this set, it's not phi. I have a common element C. But if you find that is phi, that means wherever I will put RP, I will not put RQ in that particular columns, I will put them another column. So definitely there is no way to have any conflict. So that means what we have seen from this example, we have also identified one more thing, that is, you see, in case of SLR, since there is a possibility to reduce this number of entry for the reduce move in case of SLR1 parsing table, that means one thing I can say, that if I can draw a LR0 parsing table perfectly for a production, I mean set of production rules or for a grammar, I mean perfectly means there is no conflict. So definitely if you design a SLR1 parsing table, you will not have, there is no scope of having any conflict, right? Because SLR1 is reducing the number of entries and LR0 parsing table contain much more entry than SLR1 table in case of reduced move at least. So definitely if the number, if there is no conflict in LR0 parsing table, then there will be no conflict in SLR1 parsing table. I can guarantee that. But the reverse one, reverse one means the opposite scenario. Like if I see that there is a parsing table, sorry, there is a conflict in LR0 parsing table, what we can do, we can try to draw SLR1 table, and there is a possibility that I might get, I mean, I might solve the conflict over there or may not. It will entirely depend upon what is follow of those left hand sides. So that means what is the, I mean, what is the point we can generate over here? That is, if uh, if a grammar is LR parser, LR0 parsable, means LR0 parser can be designed for their grammar, that implies the grammar is SLR1 parsable, surely. But opposite one, like if I say that if a grammar is not LR parsable, that does not imply the grammar is, I mean, sorry, grammar is SLR parsable or is not SLR1 parsable. You cannot make any conclusion, right? It's a very important point. Actually, these observations are very important, and from this observation, the question comes. If consider for MCQ, obviously some people will ask you about a grammar will be given and you will be asked. It comes in various question. I hope if you check some get questions, even some competitive exam question, you will find that a set of production rules, or you can say a grammar is given, and it has been asked that tell me, just give an MCQ, and some set of options is given, and it is said that it is asked that whether it is LR0 parsable or not, or SLR1 or something like that. Now, to realize it quickly, suppose that a thing is given like both is given, that LR0 parsable, also given SLR1 parsable. So you have to either select one or more both. And if you find that it is LR0 parsable, then you don't need to draw a SLR1 table. Because from the observation we have seen that if I am able to draw a LR0 parser, I can surely draw a SLR1 parser. But if you find it is not LR0 parsable, then you have to check separately. You have to modify the table according to the SLR1 logic, and then you can check whether any conflict occurred or not. Okay. So in this way, but you don't need to go through the table also. I'll suggest. You can check the even from the state diagram. Just search where I have more than one production rule, and among which there is a possibility two case. One is shift move and one is reduce move. I mean, in the same state, I will have a final item. Along with that, I will have a shift move. And if it is present in any state, definitely for that state, the corresponding row that we will draw in the table, there will be a possibility to get any conflict. So don't need to draw the entire row of the table. Don't need to draw. Just draw the row which are reflecting those states having multiple entries, and at least one of them is a reduce move. That means a final item. So you don't need to do all the table. So in this way, actually, you can minimize your time to give your answer quickly in case of some competitive exams. So this is all about the SLR1 table. I'll definitely not go to the SLR1 parsing algorithm, because the SLR1 parsing table use the same algorithm shown in previous day. This one, it will go through in the same way, because ultimately the algorithm uses SLR1 parsing table given over here. There is the difference. There is no other difference is present. So it's all about the SLR1 table. So now we can move on for the other two parser, that is LALR1 parser and CLR1 parser, and there we will see the parsing table will be much more stronger to find the error much more earlier than these two parsing tables.